ನಾಳೆ ರಜೆ ಕೊಟ್ಬಿಡ್ತೀನಿ. ನಾಳೆ ಸ್ಕೂಲಲ್ಲಿ ಗುರು ಪೂರ್ಣಿಮಾ ಇದೆ ನಾಳೆ ಬೇಡ ಅಂತ ಇವತ್ತು ಹೇಳ್ತೀನಿ ಹೇಳಿಲ್ಲ. Good afternoon, children. So axioms, I got only a few, eight are remaining. So what to do for them? So when homework is given, try to follow. It is for your benefit we are giving the homework. You should not think that it is burden. You should do your work with pleasure, right? So who are not done, this time an excuse. But next time, if homework is not done in time, you are removed from the broadcast group. Okay? So what audio you have sent, listen it repeatedly, because when you move forward, you have many more theorem statements, axioms and all. You should not get confused. That is the reason I made you to do practice with your voice only. So when you hear your voice instead of teacher's voice again and again, that will be much more pleasure with you, so that it easily fits in your mind. Okay? What audio you all send, try to repeat it by listening. That will confirm in your mind. And also, whenever you listen the audio, try to frame the figure. For example, if a ray stands on a line, immediately you write one line and a line and a ray on it. According to the statement what you have read, same thing you put up on a sheet of paper with diagram. That will be more helpful rather than simply by hearting it. Okay? Practical with theory, like that. And still more confirmation, you can do the activities whether it possible, it satisfies, whether the corresponding angles are equal, the lines are equal, constructing corresponding angles and checking the lines will equal. When the lines are equal, their corresponding angles are equal. Similarly, if a ray stands on a line, then the adjacent angles form a straight line. You can do the cut and paste activity. That will be 180 degree. Like that, practically also you can convert what video you have sent. I'll read out those who are sent the videos, that is audios, according to the homework what I mentioned. I'll thank to them: Shravya, Yashas, Samita, Shriya, Bhuvan from Bhuvan BV, Kaushik, Yashas, Aditya, Divya, Adya, Kusum, Madhumita, Jeevita, it is not Jeevita, it is Tanya, Grishma, Vismaya, Varshini, Srikantaras, Srishti Patel, Nishan, Aryan, Varshat, Aishani, Sonika, Aishat, Anand, Grishma, Aditi Shetty. Remaining Raghavi, Prajwal, Shravya, Dhruti, Lohit, Hansini sent, Maulya, Kevin. These many not yet sent. So I don't want your excuses. When I mention the time duration also, it is your responsibility to give up your answers or work in time. Okay, na? So when you are, suppose if you are absent for the yesterday's class, you could have listened the audio, then you will get an idea what to do. So don't continue your absence or continue your excuses for next set of questions. Okay? Thank you. We will continue now. Yesterday we discussed about theorem. Discuss about the theorem, that is 6.1 theorem. When two lines intersect, then the angles so formed, vertically opposite angles, are equal. Based on that, we worked out many more problems. Still more questions I have to do. Before that, yesterday we started the pair of corresponding angles are equal, the lines are parallel. If the lines are parallel, the pair of corresponding angles are equal. So based upon this corresponding angle axiom 6.3 and 6.4, now we have the theorem. What the theorem? If two lines are intersected by a transversal, then the pair of alternate interior angles are equal. So please take down the theorem statement. Theorem 6.2. Take the heading as Theorem 6.2. Under that, so whenever you want to prove the theorem statement also you have to write up as it is. So practice the statement also. According to theorem 6.2, if a transversal, take down this, if a transversal intersects two parallel lines, then each pair of alternate interior angles, then each pair of alternate interior angles is equal. So to prove this, we use axiom 6.3. That is, if two lines are parallel, then the corresponding angles are equal. Now, using that axiom statement, we are going to prove if two parallel lines are intersected by a transversal, then the pair of alternate interior angles is equal. Based on the theorem statement, it is theorem 6.2. We have a figure like this. Get the figure. Do it in your notes. Use scale and pencil for the diagram. This is a transversal. Name it as small letter PQ. Intersected at point A, B, or else we'll name according to the book mentioned. A, B, C, D, Q, R, S. So according to the textbook figure only, I have given the name with the letters A, B, C, D, P, Q, R, S. Okay. So here, these two are alternate interior angles. Okay. That is angle AQR, DRQ, BQR, CRQ. So now L and M. So I just mentioned the lines with the letter L and M. Where to identify the angles, I use the letters A, B, C, D and transversal PS. Its point of intersection at Q and R. Get the figure? Okay, na? I will show you using numbers, then we can use the letters for identifying the angles. Here, don't do M and okay, take like this only. AB and CD are two parallel lines intersected by the transversal PS, intersecting the lines at Q and R. It is given AB and CD parallel lines. PS is a transversal intersecting AB and CD at Q and R. To prove angle 1 equals angle 2, angle 3 equals angle 4. They are pair of alternate interior angles. To that, prove angle 1 equals, that is, we name it apart from 1, 2, 3, 4. Angle 1 equals angle 5. Why angle 1 equals angle 5? What is the reason? Why angle 1 equals angle 5? Give me the answer. Yes, very good, Shrikant. They are vertically opposite angles. 1 equals 5. Angle 1 equals angle 5. But angle 1 equals angle 2. Oh, sorry. Angle 5 equals angle 2. Why angle 5 equals angle 2? Yes. After 1 equals 5, they are vertically opposite angles. Why 5 equals angle 2? Yes, Bhuvan. Yes, they are corresponding angles. 1 equals 5, 5 equals 2, which implies angle 1 equals angle 2. They are pair of alternate interior angles. This is how we prove the pair of alternate interior angles are equal when a transversal intersects two parallel lines. Very good. Everybody is responding. Now I'll move to the statement now. According to the theorem part, we require certain steps. We follow the step. What is the first step you have to write? Given. Below the figure you write given AB and CD are two parallel lines intersected by the transversal PS at R and Q. At Q and R, I'm sorry. Q and R. Are you able to see? To prove angle BQR. Angle BQR. BQR equals CRQ. Angle CRQ. And angle AQR equals angle DRQ. If you show one pair, then you can write similarly. Okay. Now, given we have mentioned, to prove we have given. Now we'll go with the next step is proof. Proof. angle BQR equals angle AQP bracket vertically opposite angles. Take it as result 1. Also, angle AQP equals angle AQP equals angle CRQ bracket corresponding angles. Result 2. See the result 1 and result 2. Then you write from 1 and 2 we get. I'll continue here. From 1 and 2 we get angle BQR equals angle CRQ. Similarly, angle AQR equals angle AQP. So here I mentioned numbers. To recall, you can use the number. That is 1 equals 5, 5 equals 2, therefore 1 equals 2. Similarly, 3 equals 6, 6 equals 4, therefore 3 equals 4. So just if you put the number, you can easily identify the angles using letters. Okay, na? That is angle BPR equals AQP. They are vertically opposite angles. PQA or AQP equals CRQ, corresponding angles. So this is the common angle we consider this angle. So these two angles will be equal. Okay, na? So once you prove that, you can immediately next line you can mention. Similarly, other pairs are also equal. That proves theorem 6.2. 6.1 is regarding vertically opposite angles. Proving of two vertically opposite angles. Theorem 6.2, proving alternate interior angles. So here alternate interior angles we prove using corresponding angle axiom. How corresponding angle axiom? If two parallel lines are intersected by a transversal, then the pair of corresponding angles are equal. Based on that, we proved alternate interior angles are equal. 6.3 is its converse. Converse, if alternate interior angles are equal, then the lines must be parallel. That is, if you prove it is given 1 equals 2, 1 equals 5, therefore 2 equals 5. Axiom 6.4 refers, if the pair of corresponding angles are equal, the lines must be parallel. That is the converse statement of theorem 6.2. Is it clear? When two lines are parallel, the alternate interior angles are equal. Conversely, if a pair of alternate interior angles are equal, then the lines must be parallel. Yesterday only I have given a simple example. If you study well, you will get the good marks. If you get the good marks means you have studied well. Like that, converse statement, if alternate interior angles are equal, the lines must be parallel. If the lines are parallel, their alternate interior angles are equal. This is how the theorem proves. Clear now? I will move on to theorem 6.3. That is, if a transversal, we'll write the statement again. So while doing only you will get an idea, even 100 times, and if I repeat it also, if you compare the statement with the figure what you have taken, it is very much clear. Okay. Theorem 6.3. Take the statement. Theorem 6.3. If a transversal intersects, if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Here to prove this, we use axiom 6.4. To prove previous theorem, we used axiom 6.3. Now the statement is clear. In the previous statement, it was given if a transversal intersects two parallel lines, then the alternate interior angles are equal. In this statement, it is given if two lines are, it is not a parallel dimension, if two lines are intersected such that their pair of alternate interior angles are equal, then the lines must be parallel. So please read the statement again and again, most important. Okay. Here to show the lines are parallel, we have to show that their corresponding angles are equal. Again, let us have the figure based on this statement. Get the figure. Same letters I will use so that you won't get confusion. Okay. A, B, C, D. A, B, C, D. Transversal, P, Q, R, S. It is given angle 1 equals angle 2. Let's go. This is enough. That is, if a pair of alternate interior angles are equal, then the lines must be parallel. If a transversal intersects two parallel lines, then the pair of alternate interior angles is equal. So what statement we have taken earlier, to that the proof it is in converse way. In the earlier what we have given, lines are parallel, we have to prove alternate interior angles are equal. Here, is it clear? Can you all see the board, please? Here, alternate interior angles are equal. We have to prove the lines are parallel. In theorem 6.2, lines are parallel. We need to prove their alternate interior angles is equal. Got the difference? Previous statement, present statement. Repeat the statement along with the theorem number. Whenever we want to quote, we have to refer yes according to this theorem. So repeat the theorems again and again. One more homework today I will give up. That is, try to write up the axioms and theorem statement in a bold letter. Paste it in your reading place or on the fridge, on the alamera, on the back side of the calendar. So whenever you go around, you have to see that visual, colorful statements, axioms. Then while doing, you can recall those statements. This is another homework. And one more point I want to announce. Tomorrow you don't have your online class. Okay, due to Guru Purnima at school, I am not able to come in early. So, no online class, but Sunday you have your test. Test is on number system and statistics. Is it clear? Once again, I will send through the WhatsApp also. Anyway, but safer side, I am telling tomorrow, no online class. Try to practice number system and statistics for Sunday test. Okay? Yes, now here we write what is given. Given AB and CD are two lines. They are not parallel. Here they were parallel. Now here only two lines intersected by transversal at Q and R such that angle 1 equals angle 2. For the converse, I am using the numbers. That is not given, the proof is not given in the textbook. Only main theorems, I will use the letters. For the converse, I am using the number. What is given? Angle 1 equals angle 2. To prove. What we must prove? Come on, tell me. What you have to prove? Tell me please. To prove, come on. What you have to prove? You are not following. Alternate interior angles are given. What you have to prove? Yes, Samhita, AB parallel to CD. Very good, Grishma. AB parallel to CD. To prove AB parallel to CD. To this, I will write the proof. So, you are all observing that I am writing in each heading given to proof and all. So, you have to follow as it is whenever it is for the theorem or whenever it is for 3 or 4 marks question. Very good. AB parallel to CD. I will write the proof. You have to write the continuation here only. Since you are not able to see, I am continuing here. Okay. Proof. Angle 1 equals angle 2. It is given in the question. But angle 1 equals angle 3 vertically opposite angles. Vertically opposite angles. Angle 1 equals angle 2. Angle 1 equals angle 3. What we get? Which implies, if I write like this, equal sign with arrow, which implies angle 2, if angle 1 equals angle 2, angle 1 equals angle 3, which implies angle 2 equals angle 3. But these are what? But these are, what about angle 2 and angle 3? But these are Yes, but these are very good pair of corresponding angles. Pair of corresponding angles. Corresponding angles. According to axiom 6.4, if the corresponding angles are equal, the lines must be parallel. Therefore, AB parallel to CD bracket axiom 6.4. According to axiom 6.4, if a pair of corresponding angles are equal, the lines must be parallel. According to axiom 6.3, if the lines are parallel, their corresponding angles are equal. Very good. Everybody is interacting. That I like. Usually in geometry, we have to analyze what is given, why we are following, what property, what axiom, what statement. For everything, answer from your side is very, very important. Fine, very happy. Therefore, AB parallel to CD. So, in the previous theorem, we proved if AB parallel to CD, then corresponding angles are equal. In theorem 6.3, if the alternate interior angles are equal, then the lines must be parallel. If the lines are parallel, their alternate interior angles are equal. If their alternate interior angles are equal, then lines must be parallel. Very good. Is it clear to everybody? Now I will move on to one more property of the parallel line, that is sum of co-interior angles. We also call it as allied angles. Co-interior angles is supplementary. We are going to prove. Now this is the first time you are introducing with the heading theorem. Whenever it is theorem statement, you should get the theorem statement with figure given to prove, then proof. So these steps you have to follow. Now onwards you have all those theorems you have to undergo with the theorems with the heading, what is given, what you have to prove, any construction, then the last part is proof of the theorem. Is it clear to everybody? Now I will move on to next theorem. But now apart from your axioms, you have to practice the statement of theorem 6.1, theorem 6.2, theorem 6.3. That is, according to theorem 6.1, if two lines are intersected, the angles, the vertically opposite angles are equal. Theorem 6.2, if a transversal intersects two parallel lines, then the pair of alternate interior angles is equal. Theorem 6.3, if a transversal intersects two lines such that alternate interior angles is equal, then lines are parallel. Again you have to practice apart from the axioms this theorem statement also. Okay na? Now I will move on to theorem 6.4. 6.3 over 6.4. Actually 6.4 and 6.5 proof is not given, but the property we are going to use, I am going to give the proof of this. In textbook they are not given, but I will give the proof because while doing the problems this statement is applicable. So now take the heading theorem 6.4. Theorem 6.4. Take the statement. If a transversal intersects two parallel lines, if a transversal intersects two If a transversal intersects two parallel lines, then each pair of interior each pair of interior angles on the same side of the transversal is supplementary. Supplementary means sum of two angles 180 degree. So we can also state this: if a transversal intersects two parallel lines, then sum of co-interior angle is 180 degree. Sum of the allied angles is 180 degree. Yes, Yashas, you are right. Get the figure. Listen, this proof is not in your textbook, but I am going to give. So whenever you get co-interior angles, this statement along with the proof you can recall. That is the reason I will write PQ or yes. This statement you have to recall, that is when a transversal intersects two parallel lines, then the sum of co-interior angles on the same side of the transversal is supplementary. I will name it 1, 2, 3. Get the figure? Over. I will explain it. First listen the explanation, then we can write the steps. The first point, what is given? Given AB parallel to CD. Listen the explanation, don't write anything. Listen the explanation. Given AB parallel to CD, PX is a transversal intersecting at Q and R. What is given? AB parallel to CD, PS is a transversal intersecting at points Q and R. To prove angle 2 plus angle 3 equals 180 degree. That is supplementary means sum of the two angles is 180 degree. To that, listen the proof. Ray QB stands on PS. See, ray QB stands on PS. So 1 plus 2 equals 180 linear pair angles. But 1 equals 3 corresponding angles. Therefore, 2 plus 3 equals 180 degree. Hence, proof. That's all. Okay, na? Let us write. Given AB parallel to CD, PS is a transversal. Trias is a transversal intersecting the lines intersecting the lines at Q and R to prove angle 2 plus angle 3 equals 180 degree. Since this proof is not in the textbook, I am using the numbers. Similarly, these two angles are also supplementary. I am showing now only 2 and 3. Okay? I will write the proof here. Ray QB stands on line PS. Therefore, angle 1 plus angle 2 equals 180 degree linear pair angles. You can also write here axiom 6.1. That is also right, or here 1 plus 2 equals 180 degree linear pair angles. But angle 1 equals angle 3 corresponding angles. Don't write CA, LPA. Okay? Don't abbreviate the answers in the bracket. Write completely linear pair angles, corresponding angles. Here 1 plus 2 equals 3. I can replace 1 as 3 because 1 is equal to 3, which implies 3 plus 2 equals 180 degree, hence proved. Hence proved. Is clear? If a transversal intersects two parallel lines, then the sum of co-interior angles is supplementary. Here I have proved using the numbers because this proof is not in your textbook. Only application of the proof, application of the properties there. That is the reason they are not given. But for your safer side, I have given this. You can make use of this proof along with other two theorem proof. Okay, na? Is it clear to everybody? If I ask you to write the theorems, are you able to do? One fine day I will call 10 students here to work out the theorems in front of me. I will make the batch 1, batch 2. Then at that time you should come over here and do the test in front of me. MCQ is okay. For descriptive we require the students in front of us only. We will do that. Okay, na? So what is the converse? Here, converse of the statement is, if the sum of co-interior angles is supplementary, then the lines are parallel. If the lines are parallel, co-interior angles is supplementary. If the co-interior angles is supplementary, the lines must be parallel. We'll do the theorem 6.1, 6.2, 6.3, 6.4, then 6.5. Take the next statement, theorem 6.5. Take the statement, if a transversal intersects two parallel lines, two not parallel lines, two lines such that a pair of interior angles on the same side of transversal is supplementary. Transversal is supplementary. Then the two lines are parallel. If they are parallel, their co-interior angles is supplementary. If the co-interior angles is supplementary, then the lines must be parallel. Get the figure? A and B, AB, CD, P, S, Q, R, 1, 2, 3. See the statement. If a transversal intersects two lines such that the co-interior angles on the same side of the transversal is supplementary, then the lines are parallel. I will explain the theorem here. Given AB and CD are two lines such that 1 plus 2 equals 180 degree. To prove AB parallel to CD, prove 1 plus 2 is 180, 1 plus 3 is also 180, therefore 2 equals 3, but these are pair of corresponding angles. According to axiom 6.4, the lines are parallel. I hope it is clear. After doing these many theorems, now it is clear for you all how to proceed the theorem. So we'll start now after the figure with the heading given AB and CD are two lines intersected by a transversal PS such that angle 1 plus angle 2 equals 180 degree. That is, sum of co-interior angles on the same side of the transversal is supplementary. To prove AB parallel to CD. In the previous theorem, what we proved, since AB parallel to CD, the sum of co-interior angle is supplementary. Here, if the sum of co-interior angles is supplementary, then the lines are parallel. To prove it, now we will go with the next step. It is proof. Proof. Angle 1 plus angle 2 equals 180 degree. It is given in the statement. Sum of co-interior angles is supplementary. But angle 1 plus angle 3 equals 180 degree linear pair angles. So now we compare the result 1 and result 2. In those two results 180 RHS are same. So we are equating from the result 1 and 2 we get, from the result 1 and 2 we get 1 plus 2 equals 1 plus 3. Cancel this 1. Therefore 2 equals 3. 2 equals 3. These are pair of corresponding angles. But these are pair of corresponding angles. According to axiom 6.4, if the pair of corresponding angles is equal, the lines are parallel. Therefore, AB is parallel to CD. Hence, proved. Clear? Now write from theorem 6.1 till 6.5. You have the theorems along with the given to proof also. You have to practice one after the other. Now based on this, now I'll give simple problems to identify, to find out, to clarify, to compare the problems. Okay? Is clear now? Everybody is clear? After your Sunday test, practice these statements. When you come for next class, these statements are very, very important to prove the riders. Riders means problems based on the theorems. You have many more riders you have to prove. Geometry means full of proof. So you should have a little bit patience to practice, and with pleasure you have to practice. Okay, now I will give few questions which are based on these theorems. That's a simple. Still I am not touching the worksheet what I given. Only concentrating to the statement as well as proof of the theorems. Okay, but slowly practice. Anyway, tomorrow you have the gap. Practice these theorems along with your test portion, that is number system and statistics. Clear? Yes. Now we have the problem. Take the figure. Theorem. First question. This type of question yesterday only you answered. Again from the beginning I am including this. Get the figure. What is x? What is the value of x? What is the value of x? Yes, they are vertically opposite angles. Get the figure. Below the figure you write angle AOD equals angle BOC. Reason vertically opposite angles. Therefore, x equals 42 degree. Using scale, underline the answer, the value of x. Okay. Next question. Question number 2. What is the measure of x? Reason why it is 53 degree. Yes, they are corresponding angles. You write here AB parallel to CD, therefore angle, I will name it 1 and 2. Angle 1 equals angle 2, corresponding angles. Corresponding angles. Therefore, angle 2 equals 53 degree. Next question. Let us name it as 1 only. Find the measure of x. What is angle x? Yes, Sonika Prasad, it is 132 degree. Yes, 132 degree. Here we use linear pair angles. Yes, Divya, you are right. Then corresponding angles. Okay, na? First linear pair angles, then corresponding angles. I will write here angle 1 plus 48 degree equals 180 degree, linear pair angles. Is it clear? Linear pair angles. Therefore, angle 1 equals 180 degree minus 48 degree. Angle 1 equals 132 degree. But angle 1 equals angle x, corresponding angles. Corresponding angles. Therefore, x equals 132 degree. So, don't consider always you will get the direct relation. Sometimes you have to use vertically opposite angle, linear pair angles, then alternate, then corresponding, or then co-interior angles. So, based on the figure you have to analyze what is given, what property is applicable. Okay, na? Next question. So find x and y. I'll write here this is x and this is y. What is the value of x? What is the value of y? X is 122 degree, y is yes 58 degree. Fine, right? AB parallel to CD, therefore angle x equals 122 degree. Reason, alternate interior angles. At 122 degree plus y equals 180 degree, sum of co-interior angles. Therefore, y equals 58 degree. X equals 122 degree. They form alternate interior angles. Y plus 120 degree. You can also use linear pair also. Okay. Now, is it clear? So, from the given figure, calculate, given here angle PQB is 108 degree. So, now you have to find out angle 1, 2, 3, 4, 5. All the angles. Knowing one of the angle PQB is 108 degree. What is angle 1? Angle 1 plus angle PQB equals 108 degree. Linear pair angles. Linear pair angles. So, angle 1 equals 180 minus 108 degree. Angle 1 equals 72 degree. Correct? Okay. After getting 1 equals 72 degree, then we can write angle 1 equals angle 2 corresponding angles. Right? Angle 1 equals angle 2. Therefore, angle 2 equals 72 degree. But 2 equals 3. Angle 2 equals 3. Reason? Alternate interior angles. Therefore, angle 3 equals 72 degree. Next, angle 3 plus angle 4 equals 180 degree. Co-interior angles. you can use these co-interior angles, or also you can use, they are corresponding angles. So now angle 4 equals 108 degree. Again angle 4 equals angle 5, alternate interior angles. Alternate interior angles. Therefore, angle 5 equals 108 degree. You can also show 108 degree and 5 are vertically opposite angles. So here, which are the types of angles we can use? Linear pair, vertically opposite angles, corresponding angles, alternate interior angles, co-interior angles. Okay? Condition, only thing is you have to find out the unknown angles. Clear to you everybody? So practice all the theorems 6.1 to 6.5 with the statement. You have to write up the statement. So do one thing, write all the statements like what we did yesterday. Like that you read out all the statements from 6.1 to 6.5. Please send your audio after your test. That is, after Sunday test got over, you can send your video. If it is okay, you can send today itself, or else you do practice for Sunday test. Okay, and send your videos and audio regarding 6.1 statement to 6.5 statement. And those couldn't answer yesterday's work, please cooperate with me. Come to your confidence level. Unless you practice it regularly, it's very difficult. Kevin from DMS, and then Maulia from St. Joseph, Maulia from Jesus, then Punya from Jesus, St. Joseph, and many more, that is 8 students. They haven't given up the answers. Practice it. And once again, I am telling, tomorrow no online class. Suppose if I get the link also, I will do the problems in the next Thursday class only. So you practice your test portion, okay na? And try to get ready with your Google Meet. Try to download the Google Meet. I may call anytime. You should be get ready for interaction class. Okay na? Thank you children. Those who are answered, for them, thumbs up. Thank you. Dhruti, you didn't send the audio. Dhruti are right? I didn't get Prajwal from your side audio. No, I'll check it once. Why, Dhruti? Your sister is so punctual. Okay, I'll give the time. Thank you.